Thanks for joining me for MTI's Whiteboard Wednesdays. I'm Dan Adams. Today we're talking about direct drive versus low force friction welding for axles. Today we're going to talk about the friction welding of axles. This might be tubes, flanges, banjos. Axles are a traditional friction welding application and they're made by the millions every year. So we want to look at it with respect to direct drive and our new process, low force. One of the reasons why axles are made with direct drive friction welding is because they're made from a hardenable steel. And we need to get a bunch of heat into the part so that we can control the cooling rate, avoid the formation of martensite, and improve the fatigue performance. So we bring the spindle or the flange up to a rotating speed, the set RPM. The two parts are going to come into contact under low pressure. We call this first friction. This might clean up dirty parts that are coming in, square the interface, reduce the amount of friction so that we don't stall the motor when we bring on a higher load. In second friction, we have a higher load. We're now building more heat, and this is where we start upsetting the component. In direct drive of axles, this second friction phase is going to be much longer, again, because we want more upset in order to drive more heat into the component to be able to control the cooling rate. So once we get the desired amount of upset, we bring the spindle down to 0 speed, we bring on forge force, and the weld is complete. If we look at this application, this is a tube to a flange. So you can see the flash curl. This is a relatively small component. These things can get up to 6 inches in diameter. And the flash formation is going to grow considerably as the part gets bigger. But you have a very tight flash curl, which makes it difficult to remove. Sometimes these are sheared off. Sometimes they're turned off with a 2-axis flash removal process. But this might also represent what might be an E-axle application. So it's important for us to look at this with respect to the future. If we look at the low force process, we don't need to build that heat under load. We can do it with a preheat operation. Now we can bring on a first friction or a second friction phase, or we can just bring on full forge load from the beginning. But our heat is going to be driven from an external source. We can get that heat in very quickly. We don't have to do it with a long amount of cycle time. And as a result, we don't have to create a whole lot of upset in order to make the same weld. So making welds with much lower upset can be key in the axle application. And then if we need to, we can apply a post-weld heating operation as well if we need assistance in controlling the cooling rate based on how we put the heat in to begin with. Here is a large diameter tube being welded to a spindle. So this is the traditional application with respect to axles. You can see in this case welded with low force. There's very little upset here. There's no big flash curl. This is just a bulge. We can't remove the ID flash, but you see the same bulge on the inside. But as a result of that, there's no big stress riser here. So you're going to get improved fatigue performance as a result of that. The part is designed based on its fatigue performance, so if I don't need the strength in the weld because of the stress riser, I can decrease the wall thickness of my components, thus providing a lightweighting opportunity. So it's important as you look at an axle application to consider the entire manufacturing process and even part design if we're going to really take advantage of the value of low force. We can get welds done with lower upset, so we want to look at what the incoming parts look like. We want to look at the incoming part design. What sort of post-weld operations are we doing? We might be able to remove equipment out of your entire manufacturing line as opposed to just replacing a direct drive machine with a low force machine. We have the ability to do these welds in low force in our factory. So we can walk you through the development process, make sure that you understand what the values are, give you parts that you can go off and test your own so that we can help you redesign your manufacturing process and drive your cycle time down and the value of the components up. Thank you for joining us for this episode of MTI's Whiteboard Wednesdays. For more information on this topic or other friction welding solutions, please visit our website at mtiwelding.com.